Hello, everyone. If anyone's watching already, just getting started, making sure the stream is live. And it's always useful if you can hear me or see me, let me know in the chat. It's always good to have someone double check. And I'm just going to post this somewhere. Let me know, too, if you're watching, where you're watching from, why you're interested maybe in computer vision or ML monitoring, if you have a use case in mind or something you're already working on. I always love to hear that. Has anyone been messing around with GPT chat this week? I feel like that's all my social feeds have been around AI. I see some people already here. We'll get started in just a minute. I'm going to give 1 or 2 minutes for people to join. So again, if you're watching, let me know in the chat where you're watching from, why you're interested in computer vision or ML monitoring, and if you have any specific use cases. And again, if you want to let me know that you can hear me, always good to have someone else let me know that I'm coming through. If you're watching on YouTube, all the links to follow along are in the description, and I'm going to go ahead and post those in chat real quick, just so I'm also streaming on LinkedIn, just to make sure people also have those links. The main one is you're going to want this Colab notebook link to copy and run the code. Most of what we're going to be doing is running code, and you'll also want to sign up for a free WhyLabs account. That's what we're going to be using today to do the ML monitoring piece. So I'm just going to post these in chat, and then we'll get going here in a second. And someone let me know that I'm coming through loud and clear. Thank you for letting me know that. And let's go ahead. I'm going to share my screen, and we'll get started. And I'm sure some people will join in a few minutes, or some more people will join in a few minutes. I just have a few slides I'm going to go through, and then we're going to get to the code. So don't worry, there won't be too many slides. This is mostly going to be, hopefully, a fun hands-on experience. But just to introduce myself and some of the stuff that we're going to go through today, I just have a few slides, and then we'll get to the code. And again, the links for everything's in the description. And also, I always love it. If you're watching, please, comment in the chat, ask questions. Let me know what you find interesting. I'm hopefully going to be asking you questions, and it's always more fun if people answer them. But no worries if you want to stay quiet as well. So today, this is computer vision. We're going to be building a computer vision model with TensorFlow and Keras, and then we're going to talk about how we might monitor that, specifically kind of the monitoring that happens in production. And if you haven't used ML monitoring or computer vision before, don't worry. Hopefully this is going to be a fun and friendly introduction to both of those things. We're going to build our models with TensorFlow/Keras, and then we're going to do monitoring with WhyLogs, which is an open source library, and WhyLabs. No previous experience is expected, but knowing some Python or machine learning concepts could be helpful, but just don't worry. If it's all new to you, hopefully it'll be fun and you'll learn a lot going through it. And you're always feel welcome to ask questions. So we're going to cover some high-level concepts and then implement those in a Colab notebook. And then just keep in mind, you can't learn everything in an hour, especially if you've never done machine learning or programmed in Python before. Parts of this could feel fast-paced or challenging. That's totally okay. Just stick with it and keep learning after the workshop. A quick introduction. I'm Sage Elliott. I'm a machine learning MLOps evangelist at WhyLabs. We do really cool stuff around the observability and monitoring space, making like pipelines, data and ML pipelines more robust and responsible. For over the last decade, I've worked as a software or hardware engineer, usually with startups and a couple agencies around Seattle and then Central Florida. And I love making things with technology. And sometimes when I'm presenting, I talk fast, so I apologize if it's fast for anyone. about you. So I see some people watching. Where are you from? Why are you interested in computer vision and or ML monitoring? I would love to hear from at least one or two people in the chat, and it's cool to kind of learn a little bit about the audience and kind of tailor some of the stuff we talk about. So I'll give everyone a minute to answer in there. Also, feel free to introduce yourself even if I move forward. And then also another link in the description that you might be interested in is to a Slack channel called the Robust and Responsible AI Slack. It's a great place to join and ask questions. I'm in there all the time. And yeah, connect with other industry folks as well. So setup for anyone who wants to follow along, which I totally encourage. You just need a Google account because we're going to be using something called Google Colab. And you need a Google account to run it. And then WhyLabs free sign up. So again, the link is in the description, but I will share this one more time in the chat as well. And that's all we need for setting up to actually run everything today. And someone said they're a QA engineer pursuing their master's in data science and engineering. That's awesome. Have you worked on any interesting projects that you want to share or anything? Have you done computer vision before or any ML monitoring? Ooh, and they said their interest in computer vision would be for their dissertation. That's awesome. I love computer vision. So again, if you have any questions about it, connect with me on LinkedIn or join the Slack. And if you have questions or issues with it, let me know. Computer vision is a lot of my ML background. So depending what you're doing, maybe I can help you there. All right, so real quick, what is TensorFlow/Keras? TensorFlow is a framework that is maintained by Google. It's really popular in deep learning, and it's used a lot for computer vision, and has some really cool transfer learning methods that we're going to use today. So we're going to take a ResNet 50 model today, which is a model that's really good at image classification. We're going to take a pre-trained model, which means it was already trained on a whole bunch of images, and then we're going to take that model and adjust it on our own data set today. So it'll learn from our data set, but it's going to use something called transfer learning, which you can really think of as just, it's not starting from zero. So it's able to learn very quickly about our new data set, and it works really well in most cases. And TensorFlow has a really cool ecosystem for doing the deep learning, deploying the models to the web, deploying them to mobile and edge, and just a lot of really cool production stuff. I know there's always a thing of like PyTorch versus TensorFlow. I really like both of them. I do think TensorFlow has a really cool kind of ecosystem for deployment that PyTorch is kind of catching up still to a little bit. What is ML monitoring? ML monitoring is a collection of stats and performance data and metrics from every part of the ML system. You've probably looked at some of these if you've done machine learning, like performance metrics such as accuracy, precision, F1 score, those types of things. But a lot of the times there's other areas in your pipeline where, like we like to say, bad data happens. So you have your production environment. That's where you could be doing the training, your inference, your feature store. And we're going to be collecting some telemetry from that. And then we're going to kind of log that telemetry somewhere. In this case, we're going to use WhyLogs, the open source library, to collect that telemetry. And then we're going to log it to WhyLabs. It integrates really easy with WhyLogs. And we're able to kind of monitor our whole pipeline from anywhere that we want. We can log that data and kind of measure different metrics and see how our not only how our model is performing, but kind of what our data looks like and how our pipeline is performing. And again, we'll see what this looks like hands-on in a minute. And why is it important? So we have a saying that's on a sticker. If you ever see us, you should get one of the stickers. Bad data happens to good models. You could train a model and everything seems great on your validation data, maybe even at first in your real life production environment. But then data changes. You have data quality issues, data drift, model drift, bias. And sometimes you kind of want to understand like why your model is making those decisions. So we're going to talk today about implementing something to monitor for data quality, data drift, and model drift. And I'm going to talk just super quick about those. And then again, I see more people joining. We're going to get into the code very shortly. So it's just a few slides more, and then we're going to open up a Colab notebook and actually train a model and implement ML monitoring on that model. So some example with data quality issues in computer vision. an input sensor could be damaged. So in that case, that's like a camera causing bad data. Data was pre-processed and something happened incorrectly there. So I've actually done that a lot. Like I mentioned, I have a background in computer vision, and I've accidentally read in my data weird, or I did something weird too once it was already kind of in my code. So if you're not monitoring for that, that can very easily happen as well. A camera could move or be pointing in the wrong direction, or something I've seen a fair amount, and we're gonna a sneak peek is we're gonna kind of see this today is someone could accidentally turn off a light or something like that in a manufacturing facility where if you're doing like classification on bad products or something, and if the data all of a sudden becomes very dark, and you can't really see what's going on there, that would be a data quality issue. Does anyone have an example that they've seen with data quality problems, specifically maybe in computer vision? But you could also throw in other ML use cases as well. So I know the person who was going to school, if you've done computer vision so far, have you run into anything that's caused issues with your computer vision models? We have data drift. So this is where the input data for the predictions are really no longer close to the original training data. And that's not always necessarily a quality issue like we were saying with the lights. That would be kind of data drift. We're not trained to look at that dark of an image. But this could be like, it could be the lighting, like I was saying. Maybe it's not quite as dark, but it could be brighter, or there could be some lighting changes happening just from seasonality. It could be that backgrounds change. I've done some work with agriculture, and so you have different seasons, and the background changes of like animals might be on green grass, or they could be on white snow. So if you're trained only on data in the summer, the background might be all green. All of a sudden, the background changes to white, and it might throw off your model. And you have schema and pre-processing changes. Again, that actually is a little bit more of a data quality issue usually. Has anyone experienced any data drift? Looks like there's a spam person I'm gonna block real quick in our chat. All right, so examples of model drift. This is where the input data doesn't necessarily change, but your model is no longer really giving you good, let's say, classification in this case. So one example I like to use for tabular data, but also computer vision, would be like housing market. So let's say we had a computer vision model that would look at a picture of a house and try to predict the housing price. Well, the housing market's changed a lot in the last 10 years. So if we trained a model 10 years ago, the mapping of like that data to the current price of the house no longer really fits anymore. So the data itself actually isn't changing, unlike data drift, where the distribution or something is changing with the data coming in. The data isn't changing here. It's just that our model no longer really reflects the ground truth value. And so we're going to be talking about how to monitor for kind of these three things today. And again, this is super high level so far on the slides, and I think it'll make more sense when we get in and actually implement it and get like our hands kind of dirty looking at the data and investigating it. So there's some other areas of data and ML monitoring, like I mentioned at the beginning: model explainability, bias. Does anyone have, so I think I've asked this a couple times in other workshops, out of like model explainability or detecting bias, which workshop would you want to see next? So we have some really cool features coming out around this as well. All right, so that is enough slides. We're going to go ahead and get to the hands-on portion, which I think is the most fun. So again, if you're watching on YouTube, the links are in the description. And if you're watching on LinkedIn, I did post the links in the chat, so you should be able to click on them, I think, or at least copy and paste them in. The only links that you really need to do is this one, which I'll copy one more time into the chat. So this is for the Google Colab notebook, which is a way of kind of Google hosting a Jupyter notebook. And then this is the WhyLabs account. You can sign up for free, no card or anything required, very easy to sign up. Go ahead and sign up and then go to this Colab notebook. Once you're here, you want to go to File and hit Save a Copy and Drive. And if one person could let me know that worked for them, that would be great as well, just to make sure that we don't have any errors. And if that did work, then Yeah, hopefully everything should run super smooth from here. It can take a minute to copy over. And then you'll have something like this. And while you're doing that, so again, go sign up for the free WhyLabs account, save that copy, and I'll just give a quick intro of Google Colab. So Colab is, like I said, Google's way of kind of hosting a Jupyter notebook. It's really awesome. If you've never used a Jupyter notebook before, it's a great way of kind of doing interactive programming where you can write code, you can write text, you can embed images, you can embed the output of your code kind of all in one place. So it's like a very visual way of like programming, and data scientists and machine learning engineers use it quite a bit because you can run code and see outputs like kind of all in a nice place and have it kind of documented. So it's really good for experimentation as well. And then you might want to take those functions and put them elsewhere. So let's go ahead and run this first code cell. And it might take a minute for it to initialize. You'll see it going over here. It says connecting and initializing. This is going to create a actually kind of a whole little virtual environment for us. So instead of just hosting a notebook, it actually gives us a whole little Linux environment that we can even pip install new Python libraries to as well. So it said hello world in Python. And then let's go ahead and do a little bit of setup. So we're going to pip install Pillow, this specific version here. Pillow is a library that is really great for working with images. So you can read in images. You can do all sorts of cool stuff with them. We're going to use it to read in images and log some data around it. Very important. If you don't press this, you'll probably run into an error down the road. So hit restart runtime. So we installed it. Now we have to restart our runtime to get that current version of the library into our Colab notebook. So hit yes, and you'll see it's kind of initializing again and connects again. So it might take a minute or less than a minute, probably about a few seconds, and then we should be good to go to run the rest of it. All right, so we're going to use the library called WhyLabs, like I had mentioned. Oh, someone said restart error. Spelling error. Gotcha. Yeah, I'll fix this later. Also, so you said you're a QA engineer. I also have a background doing QA engineering and hardware reliability engineering. I'm not sure if you're in the hardware QA space or software QA space, but very fun. So we're going to be using WhyLabs, like I mentioned. You can go check out the GitHub. The link is at the top. Also paste it in the chat. So it's our open source library for data logging. And you can do a lot of really cool stuff with it, like monitor for data drift and data quality and model drift, all those things we talked about. And we do it in a really cool way where we take just kind of key statistical properties of your data set and then log those. So we'll see what this looks like in a second for images. But no raw data is actually really logged or leaving your system here. So just basically for images, we're going to take values such as like the mean brightness. And you can actually use these kind of just statistical values to see if your data is drifting without sending a whole data set somewhere. So what's really cool is it makes it incredibly lightweight. So these are just kind of like like fancy aggregates of summaries of your data. And then you can, what was I saying? Oh, so they're super lightweight. So what's really cool about images in particular, if you've ever worked with computer vision on an edge device or something like that, sending images up to the cloud or anywhere can be very costly. Like your T-Mobile bill could be really high if you're sending whole images up. So you can actually log just these statistical summaries about your data and then send these profiles up. And so we'll see what a profile looks like very shortly. But just want to mention, we just collect these little summaries, and then you can use that to do all those things we talked about, like measuring data drift and data quality. And it integrates into almost any Python environment, and with a ton of different tools that are in the data science and ML space. Just a quick preview here too. So it's super easy. You just import WhyLabs and in this case pandas here. And then, you would read in your data set, and then you just say log, and that creates a WhyLabs profile object that then we can do things like compare profiles to each other for data drift, or write those up to WhyLabs, or save them to disk. So very, very easy to get started. And again, we'll see this in a little bit when we get to it, but I just wanted to talk a tiny bit about it at first. So let's go ahead and pip install WhyLabs with the WhyLabs environments. Also, if you go visit our GitHub page, we always appreciate a GitHub star as well to support our open source project. All right, so everything installed here. Now we're going to go ahead and do some imports. So we're going to import TensorFlow and Keras. If you didn't know, so you might have heard these terms before, like TensorFlow and Keras. Keras used to be kind of its own library, and it was like it's a wrapper around TensorFlow. Now it's actually embedded into TensorFlow 2. So TensorFlow 2 came out, and you can actually use it right inside the library. And then what it does is it just makes it easier for us to write or make deep learning models. It's just like an API that is, at least to me, it feels more natural the way we define things. And we'll import WhyLogs. We'll also import the log image from WhyLogs, and we'll import WhyLabs writer so we can take our logs and send them up to WhyLabs. And we'll also import a couple other libraries, Pill to work with our images, OS, datetime, and pandas. So one other little setup thing, and then everything else we should be able to run very quickly. And if you do expand this, it has some details about how to go ahead and get these tokens, but I'm going to go and show you right now. So we just want to get 3 things from our WhyLabs account. We want to get our API key, our org ID, and our model ID. So I'm going to go ahead to the WhyLabs platform. I'm going to delete this old project real quick. So yours will probably be blank here if you've never had a WhyLabs account before. We're going to go ahead and hit Create Model. Let me clean up my screen a tiny bit. Also, I'm not sure if that makes it bigger for anyone. You can let me know if that looks better. All right, so on the screen, go ahead and create model, and hopefully you already signed up for your account. Hit Setup Model. Give it whatever name you want. I'm going to call this Keras December 7th. I'll just say December 7th. And then we are building a classification model today. So we can go ahead and set this as classification. You can always start as unknown and then change this later. The classification and regression here comes to when we're monitoring those performance metrics like accuracy. This just makes it really easy to log that data and then understand what's going on with our performance there. So go ahead and hit Create Project. Now we can see that it has this model ID associated with it. Mine is model 60s. Yours is probably 1 or 0. I've done a lot of models in this account, as you can already tell. So I'm going to go back to my notebook, and I'll update my model ID there. And you just want to make sure that you don't accidentally copy over any spaces or anything like that. So model ID, and then we want to get our org ID and our API key. So back in our WhyLabs platform, right actually from here, so we don't even have to go back into our menu and go to settings. We can actually just go ahead and click on this access token here. And we want to make a new access token. So again, you could call this whatever you want. I'll just say Keras Workshop. Hit Create Access Token. If you want, you can also add an expiration date on it. Your token will show up here. Go ahead and copy that with that copy button. Go back to your notebook and update the API key there. And then one last thing is we just want to grab our org ID. So it's on the same page. It's here. It's also over here. And let's go ahead and paste that in. And then go ahead and you can hit that play button, or I often hit Shift Enter so you don't see me hitting the play button. Hit Shift Enter, and no error, so we should be good to go. We are now able to create those profiles like we talked about and then send them up to WhyLabs, which we didn't really talk too much about yet. But WhyLabs is a place where we can store those profiles and then investigate our data and set up monitors. So when the data does drift or something changes a lot, we'll get a notification about it, and we can kind of do an EDA, exploratory data analysis, in that platform. And we'll see it soon. We're going to go ahead and now load in our data and then train a model and then start writing input data to WhyLabs. So we'll see it in action in a second. All right, so let's go ahead and clone our data set. This is a small little data set that contains Raspberry Pis and Jetson Nanos. They're both kind of little edge computing devices if you've never used them before. Inside of the data set, you'll see there's 3 folders. One's days, train, and val. So we're going to use the train for our training data set, the val as our validation data set, which is when we train a deep learning model. As we're training it, we usually... Oh, someone asked about repeating the steps. Is that for getting the API key? I'm assuming that's the steps you're talking about. So go to WhyLabs. And I already have mine here, but you'll want to get hit create project, hit setup model, type in a name here, select classification, and then hit that create project button there. And that'll create the project, and you'll want to get that model ID that gets generated here. And bring it, paste it there. And then you'll want to go to access token, give your access token a name, hit create access token. You'll see this pop up here, your API key. You can hit copy. And then you want to paste that into this API key section. And on that same page, you'll see the org ID, and we'll want to copy that org ID into the org ID section. Hopefully that covered it. Also, so if you do need to look at the instructions again, you can hit this little caret type thing. And it should expand some cells with a few images telling you where to go to get those keys. All right, so we have our, looks like you said, great, awesome. So we have our 3 folders. I mentioned train, validation, and then we have a days folder where there's several days of data in there, and we're going to use that to kind of simulate like a model in production, and we're going to stream in multiple days and see what those predictions look like. So first, in Keras or TensorFlow, you use something called a data generator, where you kind of define some metrics around how your data set's going to be read in. So we're going to say our image size is 180 by 180. That's what the ImageNet model is trained on, but also pretty common in computer vision, where you're basically squishing your images down to 180 by 180 images. We're giving the train data set the path to the train folder here. There's a seed you can set because it reads it in shuffled. But if you ever want to see what that looks like, you can use the same seed. And then we're going to pass in the image size. And then a batch size is every time this gets called, you can use something called like take one. And so when the model reads in a data set, it reads it in by batches. So there's, I think we saw, well, we'll see when we run this code, actually, there's like 69 images or something in the trained data set. And batch size of 10 means we're going to take 10 images, bring it into our model, learn from it, and then bring in more 10 more images. And so basically just like it learns from 10 at a time, and then it'll start that cycle over again. And then same thing for our validation data set. And we can see we have 68 images for training and 10 for validation. And I left this code kind of commented out here if you are using your own data set, which I totally encourage you to, if you thought this was fun, go get your own data and bring it in and train a model and monitor it. But this makes it a little bit easier. Instead of having 2 folders for training and validation, you could just have 1 folder and then do a training and validation split on it. You would just say, in this case, like 20% of it is going to be used for validation. That's just why that code is still there. So let's go ahead and look at our data real quick. Now that we've read it in, we can see this is what a Jetson Nano looks like. It's kind of like this small little blackboard computer, and then Raspberry Pi is this green board computer. And we can see class 0 is a Jetson Nano, and a class 1 is a Raspberry Pi. So real quick, let's take a second right before we train our model, and we can log this data up. And why would we want to log our training data, per se? Go ahead and run the cell. I'll talk about it in a second. So a lot of times people think like ML monitoring might start when you have a model in production, but sometimes you might want to log your whole training data set, so you have a baseline to start at, where we could say, okay, we know what our training data set looked like, and now we can start monitoring new data to see if it matches the distribution or if it's similar at all to it. So here we're using something in the WhyLabs writer where we're calling it a reference profile. We're just going to give it a name, training ref profile, so we can actually go and look at any new data and compare it against this profile in the future. And then what we're doing here is just kind of looping through each of those directories that we saw, in this case, the Pi and Jetson in that training data set. And then we're just using this log.image on the pillow image that was read in. And we'll talk more about this in a little bit when we get to the logging of the other data. I just want to go pretty quickly here and show that we can log the training data set to WhyLabs, and then we can look at what a profile looks like here as well. So I did run this and I got true. Someone said they got an error. So I will just want to make sure that you didn't miss any of the previous code cells. I know sometimes when you copy over for some reason, they might get collapsed like this. So go make sure there isn't any like hidden code cells. And then one other thing to check if you're getting an error is that you could potentially have put these in the wrong order, or there's a space or something. It should throw an error already on that, but potentially there could be something like you didn't put in the right model number. I think that might be not found exception error. I would double check those two things. Make sure you ran everything. Also, if you weren't here at the beginning and you missed it, make sure that you restarted runtime when you installed Pillow as well. But everything should work. And I'm guessing because just there's the couple things that we changed here is probably something related to the setup of the API keys. If you want to double check that and let me know if you find anything or if you missed running a code cell. All right, so we did we created a profile of our images, and what we're doing here is we're logging an image, and then we're merging these profiles. We create a profile for every image in there, and we're merging them together, which just means like we take the statistics we were talking about, and then we kind of merge them together, and we can get an aggregate of that, which is pretty cool. So we can see that when we did that, the cardinality is 68. That just means there's about 68 unique values. In this case, unique images, right? Every image is a little bit different. So it's saying, hey, 68 different things. So if you're working with tabular data, you get a count of how many different items you would have in that feature. If you scroll over, we'll look at these more when we get to the WhyLabs section, and I think it'll be more fun, a little bit more visual later. But you can see that all we're sending up are these kind of values here where it's like distribution, brightness mean, median. There's some that are left out here. And then kind of just these overall little summary statistics about our data. And you can learn way more about the way that we log image data here. I'll paste the link in the chat. So there's a cool post kind of walking through a lot of stuff as well. And again, we'll get to this in a second. All right, so real quick, back to the training side. If you're not familiar with computer vision, maybe you've never used something called a data augmentation before. Augmentations are, I think it's the best just to kind of show it. So I have a link here too if you want to learn more about different augmentations and Keras. But augmentations are a way that we can tell our model when it's learning from our data, it's going to read in that data set and then kind of do some minor adjustments to it to make sure that it kind of learns how items might look in the real world without us having them all in our data set. So in this case, all we're doing is adding a augmentation of horizontal rotation and flipping. So you can actually see that these look very similar, but they're kind of turned slightly. So there's a whole bunch of different augmentations you can add, like skewing the image, brightness. Again, go look at them in the link, but it's a cool way of like making our data set have more variations without having to collect all those exact things in real life. So, this is pretty similar. It might see a Jetson Nano turned anyway, depending on how our application in the real world. And instead of collecting one turned every single way in our data set, we can actually just use augmentation to kind of simulate them turned around. And then we'll go ahead and apply those augmentations to our data set here. the Keras auto-tune feature is a way of kind of looking at our environment. In this case, we actually didn't talk about runtime at all. If you go to change runtime type, you'll see that our hardware accelerator is none. You can actually change this to a GPU, and it's really cool if you're doing a lot of deep learning or computer vision stuff on Colab. They give you a good amount of GPU time for free. We actually don't even need to do that because our data set is so small that it won't take too long for us to train even on a CPU. And the Keras auto-tune function kind of automatically optimizes how the data is going to be called in, depending if we're using like a CPU or a GPU. So now we have our train data set and our validation data set kind of prefetched. Someone that said, can you use augmentation to simulate different lighting angles? I'm not quite sure about specific lighting angles built in with the Keras augmentation. I haven't used something like that, but you can do lighting conditions, so you can make it darker or brighter. But you're talking about like making one side, like you might be able to simulate, I guess, lighting part of it, but it wouldn't like direct the shadow, for instance. So for something like that, you could actually use a more robust like synthetic data generator, which is something people do as well. So you could actually like mock up a Jetson Nano in Unity, for example, or some other synthetic, like 3D synthetic data generator, and then simulate those lighting angles that way. That is something people do, but it's a little bit more robust, I think, than the built-in augmentation with like PyTorch and Keras. All right, so now we have our kind of data set is ready to go. Let's create a ResNet 50 model like we talked about. So ResNet 50 is just a good model for image classification. We have a function here. We're going to pass in input shapes, number of classes, and then the weights by default are ImageNet. So at the beginning, I talked about transfer learning, and that's kind of the ImageNet value here is going to pull in those ImageNet pre-trained weights, and then we're going to retrain this model, or what's called fine-tuning. So it's not starting from scratch, and then we're going to say, hey, adjust your layers to kind of look at our new image data set and perform well on it. So here we're going to say pre-trained model is equal to Keras application ResNet. So this is something built into Keras and TensorFlow where you can actually say, hey, go get this specific type of deep learning architecture. We'll see what this looks like in a second. We say include top is equal to false. This just means, and again, we'll see this in a second, we kind of cut off the last layer of the neural network and add our own layer to it. And we want to do that because ResNet, I forget off the top of my head how many classes it's trained on. Maybe it's 50. It's by default like able to predict something like 50 classes or whatever that number is, and we only want it to look at, in this case, 2, but it could be 3 or 4, and we want to kind of change what that last layer of our neural network looks like based on the type of training we want to do. So then we're going to say input shape is equal to input shapes, and that's the shape of our image, so we're going to do 180 by 180, and then pooling is average. This is a convolutional neural network kind of feature. The number of classes is equal to the number of classes we're going to pass in. Again, we're going to be 2 today because we're looking at the Raspberry Pi and Jetson Nano. And then we're going to start with those ImageNet weights, and then we're going to train it on our own data set. So then we're just going to get the inputs. Actually, I think I don't use this part. So we set the input values here, and then the output, that's just the number of classes. So you'll see this quick little part here is we brought in that ResNet without that last layer. We're adding 2 layers. Here's just, we're adding a little flattened layer and then another connected dense layer, which is just, again, we'll see this in a second. I think it's easiest to see what it looks like. And then this little part, though, is we have an if statement. That's just saying if the number of classes is 2, have an activation function of sigmoid. That is just the kind of activation function that performs well in binary classification, like yes, no, is this a Raspberry Pi or a Jetson Nano? If not, if you have more classes, you want to use a different activation function. So let's go ahead and create an instance of that function that we just made with the ResNet 50. And then you saw it took a second to download something there. That's downloading those ImageNet weights. And then if we run the other code cell, you'll see this really long graph. This is the deep neural network of the ResNet 50. And so when we pulled in the ResNet 50, it was everything above this line. And then we just kind of added these other 3 layers to it. That was that flattened layer, the dense connected layer, and then this is our binary output layer. And now we're ready to train on our 2 classes. So if we had more than one class, that little if statement function, or little if statement in the function, would add the right layer and activation function to this last part. So let's go ahead and train the model. A couple parameters to pass in is we're going to pass in how many epochs. What that means is that's basically how many times we want our model to look at our data set. So I'll hit run because it can take a minute, and then I'll explain it as well. So it's going to look at our data set this many times. It's only 2 times here because we don't have that much data. Typically, you're going to want probably hundreds, if not thousands, of examples to have a pretty robust model. In our case, we only had, 68 images we're going to train on. But you will actually see it might do fairly well because the Raspberry Pi and Jetson Nano, they don't have that many variations. And then learning rate is kind of just how your model learns a little bit, like how it steps through and learns features from the images that we're passing through. Keras has a cool thing called callbacks where you can, in this case, we're saving a model at each cycle of looking at the data, but you can do things like looking at the best model that was trained, like measure on accuracy or validation accuracy, and then save that version of the model. Here we're kind of compiling our model. We're passing in which optimizer to use, which loss function to use, and which metrics to measure our model on. And then this R50 model.fit is actually the training piece. So we're passing in our training data set. We're saying how many epochs to train for, if there's any callbacks, and then the validation data set. And we'll see that our model trained here, our accuracy went up quite a bit on our training accuracy, and then our validation accuracy was around 90 when it ended as well. So typically you want to look at these metrics like, is your loss going down and is your accuracy going up? So let's go ahead and load our model back in. So also if you open up this little folder icon, you'll see all the data set we downloaded here, and you'll see the models being saved as well. All right, so now we have a trained model. We can run the inference on an image and see what it thinks it is. So here, this one, it was actually pretty sure. Again, maybe we wanted to run the model a few more times on the data set. You can see it's actually thinks it's a Jetson. And what we're doing here is we're reading the image with the pre-processing that we already defined before, like the 180. And then we're running predictions with our model that we read in. We're passing in the image array, and then it's getting this little score value, and then we're just writing out what that score was based on if it was a class 0 or a class 1. So class 1 is Raspberry Pi, class 0 is a Jetson. Let's go ahead and look at another example. And we'll look at a whole bunch more examples in a second. The exciting part is now that we have a trained model, we can actually do a lot of stuff with it. So here we have a Jetson Nano, and it's pretty sure that's a Jetson there. All right, so we so far just looked at a couple examples in the data set, but remember I mentioned we have that whole folder of days, and there's several images in each one of those days. What we're gonna do here is I'll go ahead and run this because this is maybe the thing that takes the longest to run, especially on a CPU. We're just gonna do a whole bunch of model predictions. So go ahead and run this cell, and I'll talk through what's going on. So we're going to create a object here. This is just for us to keep track of every prediction it's making so we can log this out later. We're looking in the directory of days, and we're initializing our WhyLabs writer. So we're going to create those profiles that we saw an example of before, but now we're going to write them up into a cool part of the platform where we can start exploring them. And then again, we're just going to say for 1 through 7, we're going to go step through each of those days. There's 7 days in that day folder, and each of those folders in there contains images. So we're looking for each day folder. We're going to read in the image. We're going to open that image in Pillow, and then we're going to log that image, and we're going to pass a timestamp. By default, if you don't pass a timestamp to WhyLabs, it'll just assume it's the time that you write to it. But in our case, we're going to take those 7 days and kind of walk backwards 7 days so we can look at like a whole week's worth of image data. And so we're setting the date here and then passing that date timestamp up. So you can actually see it's only 3 lines of code on the WhyLogs and WhyLab side to read in an image and then write that profile of the image to WhyLabs. And then here we're going to make the predictions with the models. So similar to like we did before, we're reading the image with the defined pre-processing that we already did, making the predictions. And then here we have a little if statement I wrote that is just going to say, if the score is under 50, then that means it's predicting that it's a Jetson Nano. And if the score is over 50, else the class is going to be 1, which is the Raspberry Pi. And then we're going to also log the probability of it being a Jetson versus a Raspberry Pi. And then we're just going to pen those probabilities in the class and the day and everything to a Python object or a dictionary. And then we can use that later to log it. So we can see this is our output. It's looping through each day and giving us the predictions about how confident it is to be whether the image was a Jetson or a Raspberry Pi. So you should have all this output. And I see a question. The question is it better to use your computer CPU/GPU? Is there any way to do that? So if you want to use a GPU in Colab, you saw it took a minute, but it wasn't too bad because we didn't have a ton in super crazy. But often you will want to use a GPU. And if you're using it in Colab, you can go to this change runtime type. And if you do this right now, it'll restart. So I don't suggest you do this a second. But you can select a GPU or TPU. TPU is like Google's proprietary tensor processing unit, which is similar to a GPU. And this will speed up your deep learning and computer vision models if you're using something like Colab, usually pretty significantly. But because we didn't have that much data today, it actually worked pretty good on a CPU. And if you have a GPU at home, like in a gaming computer, you can use that as well. You just have to set up the proper libraries locally, which can be annoying sometimes, but once you get it to work, it usually is pretty solid. So now we basically took all these images, profiled them, getting those statistics, wrote them to WhyLabs, and then made predictions on them. So let's go back to the WhyLabs platform, and let's go home. Now you should have your project here, this whatever you named it. So I'm going to click on this little button that's going to take me directly to the dates that I wrote to. And we see now that there's actually a whole bunch of data in here. So these are all the stats that we collect on images by default with that log image function. We have brightness, mean, standard deviation, color space, pixel width, hue, saturation. Let's go ahead and click in to one of these and see what's going on. So this will give us a preview of, in this case, we're looking at the brightness, but you can click on these other ones as well. So if we look at this brightness mean over the course of the week, we can see that it's changed a fair amount, potentially, right? Like it starts off here. These are kind of the upper and lower bounds is like where those yellow lines are. So you can see that the max is 209 and the min is 180. So it's around like 180 to 210 or something like that, kind of in that distribution of like all of our images were around that brightness. And then it was around the same for the next day as well. And then this day, it looks different, right? Like there's a big drop in our medium, min, max brightness values. And then this one looks like pretty similar to what we saw before. And then this is a pretty big drop as well. And then this looks like a significant drop. So does anyone have any maybe hunches or guesses what could be happening? And do you think our model would like this or not? So we can see that our data might be drifting, where it was a certain brightness value for a few days, and then it's changing quite a bit. And we want to make sure that maybe this distribution is in our training data set, or that our model could handle this well. And we'll look at what the ground truth is on our model predictions in a second. But I want to bring up something really cool you can do already just looking at our input data. So we didn't even log any model predictions yet. We just logged like kind of those raw image values. We can do something to set up a monitor. So this is going to kind of look at this. Like here, we can visually look at it ourselves, but you'd probably want to have a monitor to automatically kind of detect when something is changing quite a bit and then let us know. So we can go back and look at our data and make sure that our models are performing well. So let's go set up a monitor. We're going to set up a monitor looking at our non-discrete values. So it's going to be looking at those numerical values, which is what the image stats are. First, I'm going to hit just enable with one click. We're going to go look at this, and then we're going to come back and look at some of the configuration we can do. So let's go ahead and hit enable with one click. We'll go back to our inputs tab. We'll go to this brightness mean, and now we can hit preview on our monitor. And so we'll just take a few seconds to run. And now it's showing a preview, and you can see that based on that monitor, which we just enabled with one click, and we'll go look at some of the options and what it's actually doing in a second. But it thinks that, hey, the data has been changing quite a bit on these recent days that we logged. So let's go back and see how our monitor is kind of figuring that. I mean, we can see, right, if we just look backwards, our data at this end, the brightness value is way different than the data over here. So definitely data is changing. Let's go back to our monitor manager. Here's the monitor that we just configured. We can hit edit. And by default, the way this works is it has this kind of 7-day trailing window. So it's going to be looking at the data, and if the data changes a lot from that trailing window, it's going to send an alert. And this is really good to account for a lot of seasonality. So you often have some slight drift in your data, but if it's really big, you still want to have some sort of alert triggered. So what we could also do, if we didn't have these 7 days to look at and we just had 1 day, so we were fortunate today, is that we had these 7 days to kind of backfill and already get some alerts. But what we could do is look at a reference profile. So remember that first logging that we did when we looked at the profile, that was us logging the training data set. What we could do is, if we don't have enough new data to really compare, we can already start by looking at any new data. Even if it's our first day in production, we can start comparing it to the training data set to make sure that the distribution's pretty close. Otherwise, if it's drifted quite a bit, then our model might not be performing as well. So let's go ahead. We're going to hit reference profile. So that means instead of looking at the trailing window, we're going to look at each of those days and see how close they are to our training data set. And I'm going to change this value as well. Basically just saying, only trigger an anomaly if there was a really massive change. Otherwise, we're going to say it's probably okay. And then you can easily set up how to get alerts from email or Slack or PagerDuty. So you can actually do some really cool stuff of if the data drifted a lot, you can trigger data annotators to go and label ground truth and then log the ground truth up, which we'll see in a minute as well. And then you could actually see if your model drifted or not, or if the data was affecting your model predictions. And you can configure email, Slack, PagerDuty, and everything in the settings and the notification digest area. So let's go ahead and hit save. And we'll go back to our inputs. Let's go back in. We've just been looking at the brightness and mean right now. We can close out this preview so the preview is still on. And let's preview our newly configured monitor, where we're going to be looking at how, which profiles changed the most compared to our training data set instead of the trailing window now. So we can see that, okay, so these pretty bright ones must be pretty close to the original training data set. This one, where it dips in, is pretty far. It's a pretty big drift distance. And then all these other ones are a pretty big drift distance as well. And we'll look at them in a second and see what's going on. But this already tells us, just from input data, that something is happening, and we should probably go make sure that our model is going to be able to handle these pretty drastically different data sets. Someone said, is there an acceptable drift distance? There isn't just one metric for it. It's going to be on your application. And by default, I mean, it depends what you're trying to do as well. So you might want to have it more sensitive. That's why it's kind of cool. You can go in and adjust the sensitivity. So when we go back to Monitor Manager, go Edit, and it was this area where you can adjust we use Hellinger distance to kind of calculate the drift. And you can say, if it only drifted a tiny bit, you can adjust this number to whatever you want. If it drifted a tiny bit, send an anomaly, or you could say a big drift. So it depends on your application really too, of like how sensitive you want this, because is it better to get way more kind of alerts and make sure that your data isn't drifting, or are you kind of okay with some drift and you'll look at it later? So it really depends on your application. Like there isn't one number. If there was, then we'd probably have that number in there. How's everyone doing so far? I know we're almost an hour in. Is it cool? Are people following along? Does it seem interesting? I know it's like pretty fast and we go through a lot as well. So like if you've never done TensorFlow or Keras, it can feel like a lot. But I always suggest like to come back and take a break and then come back and look at the code like kind of after the workshop and pick it apart. So let's go back to our notebook real quick. We saw we can explore kind of the input values. There are some other features we didn't talk about, like you can go look at these profiles and kind of compare them to each other in here as well. Let's go ahead and just log our prediction outputs and then log our performance, and then we can get to anything else or look at other stuff that people want to. So we had that object that we made, or that dictionary. We can look at it. Now we created a data frame with it, and so it has the file name, the class predicted, the class score that was predicted along with it. Basically, how confident the model is that it's right. So we're going to go ahead and log those now to WhyLabs. So we're going to go through for each of the day. Again, 7 days in a week. We're going to log each one, and we're going to just log the value of the data frame for each day. We're going to pass in only 2 values in our data frame though to WhyLabs. So we're going to pass in the class prediction and the class score. We don't care, at least in this case, about passing like the file name. So we're creating our profile, and then we're going to write that up. So let's go back to WhyLabs. And you can go ahead and hit refresh here. So now we have our input data, which is all this kind of image data here. And then we have our output data of our predictions, which is the class prediction and the class score. I will just quickly note, so if you have a lot of features, it can be really hard to kind of keep your outputs and inputs separate. So you can add the word output to your data frame column, and they'll automatically be separated into this tab. Today, we didn't have that many features, so I'm just keeping them over here in our inputs tab. But you can separate them out if you want. So let's go look at, first, we can go to our class prediction, kind of see what it looks like per day. We can actually go look at frequent items, because it's 1s and 0s for each class. So we have our Raspberry Pi and Jetson. And we can see that the first day, the kind of distribution of how many Pis or how many Jetsons were predicted. Looks like there was a lot of Jetsons on this day. Again, these are the predictions, not the ground truth value, though. This is what the model's thinking was in the data set. Let's go back and look at our class score. This can kind of tell us maybe something about our data as well. We can see that, remember, when we compared our training profile to, or our inputs to our training profile, that the first day or the first couple days were pretty similar. And then there was a big drop here in similarity, and then pretty big drops here. And that kind of reflects in our probability scores from our model, because you can tell that it becomes a lot less confident on these days, at least for some of the images. So the score, the closer to 100, the more confident the model is that that's the class it belongs to. And you can see that it became a lot less confident, at least in some of the images, on these days where we saw that there was kind of a big shift in our data. So let's go back and actually, before maybe we even log the ground truth, maybe it might be fun to look at the data real quick. So this is the Git library, or the Git repo where these images are at. And you can dig in and look at the images. And I'll post this in the chat as well. So let's go look in these days. And let's look at day 1 real quick. So day 1 was the one where it's pretty similar to the training data set. And when we looked at a few images of our training data set, we saw that basically it was like pies and Jetsons on a white background, right? So this makes sense that it's pretty confident there. I think it was day 3, there was a big dip in confidence. And if we look at these images, all these are really zoomed in. So our training data set basically had the Raspberry Pi and Jetson Nanos, and you could see the whole thing in there. So there's a big white background, and then basically the object that it was trying to classify. All of a sudden, this could be like our camera specs change or the schema change for the cameras, and now all of a sudden it's like zoomed way in or zoomed way out, and there's a big distribution shift. And remember, our input data monitoring actually caught this because basically looking at the brightness values, everything was pretty bright because of the white background. All of a sudden it changed a lot because now it's zoomed in to a Jetson Nano or way zoomed in to a Raspberry Pi. So there's just like a big distribution change of pixel values. And it's really cool that just those summaries of data that we logged, again, just like the brightness in that case, was actually able to track that there was a big change in our data. Another one that changed a lot was the last day. That was the worst one. And if we look at this, makes sense. This is super dark, so this is kind of like a data quality issue, like I talked about at the beginning. Like if a light went off, or yeah, I would say like a light went off in your factory and you didn't know it, and you're still running classification for some reason on these things. And remember, I think it was predicting all these last ones on our output that these were all Jetson Nano, and it kind of makes sense because the Jetson Nano is dark, so it probably associates just like darker values of pixels with the Jetson Nano. So we think probably this like whole day 7 is probably going to be pretty wrong. And we saw in WhyLabs that like the confidence score went way down on these as well. And let's look at one other one. Day 6 here, I think. This, when we looked at our confidence score, it was going down quite a bit here as well. And this, I can still see the nano pretty good. Like a light is still on. But because our training data set had that white background, the whole background here changed, and it's really throwing off our model because, again, the distribution of just like the background values really affects our model in this way. Because right now, like I was saying, it's probably picking up color, and that's probably one way it was distinguishing a Jetson Nano versus a Raspberry Pi. And so now it's associating all these dark pixels with a Jetson Nano, and it's kind of throwing off our model confidence. And we can actually go look, which we're going to do right now, to see how good our model was on these days. So even though the confidence went way down, maybe it was still performing well. And we can do that by monitoring ground truth. So this is usually done like you have to manually go do the labels, unfortunately, a lot of times. Like if you have, you're streaming in data for a few days and you might say, oh man, I think our data is drifting because I was looking at this mean brightness value and we got an alert. We should probably go have someone go annotate and say like were the predictions right or wrong, and then log those as what's called ground truth. And you can actually have kind of an automated pipeline for this. I'll talk about in a second because I actually linked to a blog post where we did that with a company called Toloka, which is really cool. So here, just added a data frame. So now we have our predicted class like we had before, but I just added the ground truth to it so we can now compare. Like here, it predicted that it was a Raspberry Pi, but it was a Jetson Nano, I think. So let's go ahead and run this. And if we log our ground truth up to WhyLabs, is very similar to the same loops we did where we're just kind of logging through each one of those days. And then we're passing just 3 columns. This is our ground truth column, our class prediction, and then our class score. And if we go into the WhyLabs platform, go to this performance tab, now we'll have information about our, let's see, our performance here. So the performance is like things like accuracy and precision and recall and false positive rate. So you can see that it definitely drops off a lot on those dark ones. Like I think in this case, it was actually predicting they were all Jets and Nanos, and that just wasn't true. A lot of them were Raspberry Pis. And you can also set monitor alerts on these as well. So you could go back to Monitor Manager, presets. So I think I only talked about setting this one on the non-discrete values, but we have other ones for like looking at data quality, as well as model performance. So you could actually monitor when something like an F1 score or your precision drops a lot when you're getting these ground truth values in there, actually send an anomaly alert as well. And then I have a whole bunch of other resources here. So I know we're at kind of our hour. And again, this is super fast, kind of a quick overview and a little bit of a deep dive maybe into some of the subjects, depending on your background. So let me know if you have any questions. I'll be hanging out for a little bit and we could kind of dive back into some things. And I have resources in here. So you should go ahead and, like, if you want to learn more about Keras, if you want to, again, sign up for WhyLabs if you didn't as well. Here's the article I was talking about, actually automatically kind of kicking off data annotation. Oh, and again, totally recommend joining the Slack because a lot of people will often have a question later, and it's one of the best places to ask the question is in there. Someone asked, what is the minimum amount of training images? Is there a fast way to label your training data? Yeah, so the minimum amount, like there isn't like a magical number for it. It depends on like how many variations you're expecting to encounter. It's good to have a good distribution of all these variations. I think a good rule of thumb is that I try to do when I'm doing at least like a hobby project is get like often like a couple hundred to get started in a lot of variations and kind of lighting that I can think of or that I can get, because you can train a model and then get new data. Like we were saying, like we could save all those images that we saw streaming in for those 7 days. We saw that, hey, it looks like there's a distribution drift between our training data set. We could take those images, add them to our training data set, at least the good quality ones, maybe not the super dark ones. And then we'd want to retrain our model, like with that black matte in the background. And then it would actually probably become good at detecting the Jetson Nano and Pi on that background instead. So again, there's no magic number for it. I would say get started with what you have. Try to get as much as you can and try to think of the variations that you might encounter and then train them. As for labeling, you said, is there a fast way to label your training data? So it depends on the type of computer vision that you're doing as well. For classification, in this case, if we go look at this data set, the way that we label these is actually just put them in a train folder, in a class folder. So like we have a folder for Jetson, a folder for Pi, and then it just reads in these values as 2 different classes. And this is a pretty common way of labeling for classification in like PyTorch or TensorFlow. And so it's like how can you quickly put these in different folders? There's tools that help you organize it. I will say if you're just getting started, you don't want to worry about a tool for it. You can just separate them yourself, put them into different folders, and then have them labeled that way. I actually also, because I was labeling thousands of images at one point for a project, for like a GAN project, I don't have good documentation here, but I actually made a little labeling tool in Python that you can just define what folders to put them in and then key bind it. So if you're going through thousands of photos, it'll like read up the photo, you hit the key, and then it'll put them into that folder. So it's a quick way of labeling for folders. But if you're using, like if you actually want like project management stuff, like saving all those images and having other people do it, there's a whole bunch of different tools for it. I used to work at a company that built a pretty good data annotation tool called plainsight.ai, but there's a lot of different options out there. And then one thing to keep in mind too is like today we just did a pretty simple classification task where it's just reading from these folders, but in computer vision there's a lot of cool stuff like object detection or pose detection or instant segmentation, where instead of just putting them in folders, you're drawing around objects in the images, and that takes a lot longer to do usually. And so, yeah, you can use, again, different tools for it. And like I mentioned, there's a company called Toloka.ai that is really cool. And I linked to their blog post about how to kind of kick off annotation job with them. So they actually have people that you just say, hey, I want this labeled this way, and then they can go and label it. But you have to provide like specific instructions and kind of embed how you want to do it. Any other questions? I see some people saying thank you. I love the questions, everyone. Thank you so much for asking them and kind of talking as we go. It always makes it way more fun than just being incredibly quiet. And again, like if you found this interesting, let me know as well too. I know again it's a lot to cram into 1 hour. But I hope that like at least like when I'm learning something, I kind of, at least for me, kind of like it like a fast-paced thing crammed, and then like I was saying, come back and look at it, versus taking a super long time to go through. I don't know how other people feel. So let me know. Someone said they're definitely going to come back to the video and refresh. Awesome. So if you are coming back, the recording is just going to be at the same link. It might look weird for like 24 hours or something as YouTube processes it, but you can just save this link, come back to it, and then the description has everything in it as well. So if you want to come back to the notebook and stuff, everything should be in the description. And then again, you can join the Slack channel or connect with me on LinkedIn and ask me questions there. Especially, I know someone was talking about they're doing a master's and they're thinking about doing something with computer vision. I would love to hear more about what you're working on. And I'm not sure how much I can help you, but hopefully I could do a little bit, which might be cool. For people who never done ML monitoring before, was that interesting, and did it feel kind of easy to set up and get it in this whole platform where you can actually do a lot of stuff like have alerts trigger when there's an anomaly, investigate your data for drift? Someone asked, is it possible to run the code offline? For example, running the code locally on your PC. Yeah, totally. So you just have to make sure that you set up the correct Python environment. So I don't know how much experience you have. Typically, I would be doing something like this offline, but it makes it way easier to do it on Colab when I'm doing a workshop because people can just make a copy and run it. You can actually even take all of this code if you want. You can go to File, hit Download as a .py file or as a Python notebook file. And then you will just need to set up a Python environment with all these libraries. So one thing I don't think I mentioned at the beginning is Google Colab comes pre-installed with a whole bunch of libraries. So like you noticed, like we had to pip install this version of Pillow and WhyLabs, but we didn't have to pip install TensorFlow. That's because it's actually already installed in Colab. But you just need to set up your environment with all these libraries that we imported in. So you'd want to install TensorFlow, WhyLabs, Pillow, Datetime, and Pandas, and then you should be theoretically good to go to run all this code locally. And there's cool stuff too. So you can write up the stuff to WhyLabs. Makes it really easy to have a whole managed thing for alerts and to look at your profiles. I didn't really go too much into WhyLabs for this session, but WhyLabs has a lot of really cool capabilities on its own that you can always run locally just in your Python environment as well. Python or Java environment. So you can actually do things like detecting data drift and visualizing profiles and looking at data quality for validation, all kind of in your Python environment without ever having to send a profile somewhere, which is pretty cool. But at a certain point, like you typically want to write and save and compare them somewhere and have like a managed alert system. So that's why WhyLabs makes it really easy, but you can send these profiles to other areas as well. So if you go to the GitHub and you can go to the Python folder, you can go to examples. There's a whole bunch of examples. So a lot of the basic stuff you can do in WhyLabs, some advanced stuff. And we have an integration tab, which a lot of times, like we integrate with so many different libraries, or I mean, we can be used with so many different libraries, but there's a lot of cool specific integration stuff in here as well. Including like if you want to write them to S3 instead of WhyLabs. Someone said, trust me, Colab is a great platform. Helps a lot of hassle to locally installing or setting an environment. Yeah, it can be. Once you do it once or twice, hopefully it's usually not too hard if you've never set up a local environment, and it is a really good learning experience. So I do often find myself popping over to Colab and like testing something out of there, making something quick. But yeah, I mean, local development is really good. Oh, I also realized I wasn't sharing my screen anymore, and I was talking about WhyLabs. If you go to the WhyLabs Python examples integrations, there's a whole bunch of other stuff in there as well. And just the examples is a great place to start. So if you want to get set up and do basic logging locally, comparing profiles, you can do that. Yeah, local environment setup. Also, I mean, I don't know what people's preferences are. It's like some people really like using like Anaconda for managing Python environments, or you can just use the built-in Python environment manager now. Does anyone have a preferred Python local dev resource for this person we could share? I guess I could ask tech dev, have you set up a Python environment? That's a better question. Because if you have, then it's pretty easy to set up this probably to run locally. Any other questions? This is awesome. And again, like I said, I always really appreciate the questions from everyone. Anything people want to add? Anything you really enjoyed? I still see people here, so was there anything that was your favorite part of the workshop? Because I always kind of adjust them if I do them again. What would be the best thing to change for this? A slower introduction to some of the technologies, or did you kind of like going more fast-paced into it? Again, I know people have different preferences. Okay, yeah, if you set one up in the past, yeah, go look up setting up a Python environment, and it varies on the system you use too, like Windows or Mac or Linux is a little bit different. But hopefully it won't be too hard. Once you do it once or a few times, it's still, I will say, it is annoying sometimes, depending what you're trying to do. But it always gets easier. So it said the pace was a little too fast. Thank you, noted. Yeah, I might. This is my first time doing this workshop too. So the first one, I always feel like I do too fast or something, and then I'll try to slow it down next time. Maybe say with like an hour and a half or something like that might be good for it. Maybe even 2 hours, and we could spend a little bit more time on setting up like TensorFlow and Keras or something like that. But thank you for the feedback. And awesome. So I think it looks like other people are saying thank you, and they're probably gonna head out. They said the topic today was good. Awesome. Thank you so much. And yeah, I think I'm gonna head out as well, do some other work. But again, thank you so much, and thank you for all the comments and being here. And hopefully I'll talk to some of you later, again, on the Slack channel or in LinkedIn. I always love hearing about what people are working on and how I could potentially help. Someone said maybe I can do some more basic ML session, which includes some basic modeling, then deployment. So an end-to-end ML session. I think that'd be awesome. That's kind of on my list to do. Also, yeah, I do want to do. So I used to do a lot of more basic ML sessions, and I'm thinking about maybe bringing those back in some capacity as well, which I think would be really cool. Like, doing more like an introduction to machine learning, and maybe having like a series that can lead up to it. I think that'd be cool. Next week I am also doing a workshop. I'll post a link in the Slack where you can find it on Eventbrite or follow us on WhyLabs at LinkedIn. We have it posted. It's going to be similar where we're going to do ML monitoring, but we're going to use scikit-learn. And I think it is a little bit simpler to set up a scikit-learn model, then doing a TensorFlow and Keras computer vision model. So that might be one to check out too if you haven't done a lot of machine learning and you want to check that one out. Let me actually, I can bring up the link and share that as well. But yeah, I think doing like a series would be cool. And then I do want to do one with actually deploying the model. That's on my list. So again, having like a almost end-to-end thing in like that one might have to be a couple hours or a series, I think would be really cool. All right, but yep, here is the link in the chat. All right, I'm gonna go ahead and stop the stream, but again, thank you so much again for coming out, everyone, and I hope I'll talk with you all later. Have a good rest of your day.